Well, welcome everybody to today's presentation, Oracle 12c Flashback Data Archiving. Some of the things we're going to talk about here today are an extension of a previous Flashback Data Archiving presentation we did that was more based on the time dimensional or temporal data. And then today we're going to really talk about some of the additional features above and beyond that can allow you to use or save data for historical purposes, auditing, logical data recovery, things like that. A little bit about Neovera. If you haven't heard of us before, we are a hosting solutions managed services provider. We're headquartered in Reston, Virginia. We're vendor agnostic, so we have a 24/7 NOC, and we pretty much support clients from a managed services standpoint or staff aug with their DBA group to manage everything from infrastructure to the databases to client everything, and that ranges from nonprofit companies all the way into Fortune 500 companies. So we have our own presence in the NOC, our own cages, things like that, or we actually do managed services in other people's data center if that suits your needs. Some of the capabilities you can see here, we won't go through all of them, but the consulting side, I'd say some of the bigger ones that we spend most of our time with are infrastructure and security assessments. We do all the database services for Oracle, SQL Server, MySQL, some of the NoSQL type databases as well. We do handle Oracle licensing. We do disaster recovery, so we manage other companies' DR sites while they manage their production centers. And we do have multiple facilities that we operate out of. A little bit of background on myself. I am Oracle certified professional. I've been working with Oracle since version 7. I've pretty much held every role that a typical DBA generally might see, from administration to modeling to architecture across all the different types of industries. I have spoke at various Oracle users group. I've done some training days and I actually used to teach the PL SQL and DBA classes, Oracle. And some of the environments I've worked in, anywhere from Standard Edition 1 all the way to Enterprise Edition with single, multiple nodes, distributed WAN, rack setups, replication, active replication between data centers, and across data marts, OLTP, so pretty much all the different types of either application or business intelligence models. For any questions that you may have as we go through, we ask that you just put those in the text box for the questions, and at the very end I'll take all those questions so that everyone can benefit from each other's questions. Again, like I said, today's presentation is a continuation of one we did earlier, a month or so ago, and that is posted out on our Neovera YouTube site if you wanted to play catch up and look at some of that. It's distinctly different in the content that I'm presenting, so it's not, you wouldn't miss anything if you by not seeing the first one. And we're going to really talk about some of the in-database archiving capability so that you can build a history of those data changes. So those may be required for you to be compliant with regulations, or it may be part of your auditing or security practices to keep track of historical data for some period of time at least. And we'll talk about how that automatically can be purged. So there's some security around it, there's additional processes around it, and we'll talk about those today. It is, so it's called Flashback Data Archive. It is available in previous versions. 11.204 is really where they started introducing some of the pieces that if I were going to implement this today, I would at least try to be on that level for a lot of the bug fixes. It is standard and enterprise edition available, so you don't need to be on enterprise edition. The one caveat exception to that is if you want to optimize the history tables that store all this, meaning compression, and some of the blob deduplication, then you would need Enterprise Edition and you would need the optimization option. So that's the only caveat there. But the functionality we're going to talk about today has nothing, doesn't require any of these features, Enterprise Edition features rather. So a quick overview on Flashback Data Archive. So it extends the ability of the Flashback functionality, which you already have in previous versions with Flashback query, transaction, and things like that. But it actually goes beyond the data that's in the undo or Flashback logs. So there is additional background process that's created that collects and writes the data to a Flashback data archive that you've created. So typically what it does is it grabs the data from the undo buffer, and it can grab it from there, so that's pretty fast. And then also additionally, if it does need to go to undo, it can get data from undo, but it doesn't require anything in undo. So whatever's in undo is not necessarily required for it to keep those changes or keep track of those changes in the history table. And some of the uses that you might use it for is historical data changes and then you need to be able to purge that on a predefined period. You can use it to correct human errors. So if somebody accidentally does an update or delete and you need to get that back. There are some other ways of doing with Flashback functionality for transactions, but typically what we're going to discuss today is how you use that history to rebuild some of that data from a human era, and also from comparing past data to current data. So what the in-database archiving is we're going to talk about today, what it basically would eliminate is the traditional method by which DBAs would design or put triggers on a table, capture that data into a history table. And that's all fine if it's small number of tables, maybe even not a lot of change to the table structure, but that becomes very difficult to manage if you've constantly got changes to the table structures. The history tables have to be updated, triggers have to be updated, things like that. And the dependencies with that you have to keep in sync. Not to mention that triggers aren't necessarily always the fastest method. This definitely would outperform anything you would do at a trigger level because of the background process and because it's grabbing from the buffer cache or the undo from the buffer cache. So the new background process is called FBDA. So you'll see one of those just like you would SMON, PMON, all that. You'd see an FBDA. And that is what's going to collect and write the data to the Flashback data archive that you've created. So on commit, the before image of the row is put in the archive. So if you've created all this and you haven't done anything to the table, and we'll see this later on, you're not going to see all these history tables show up until it's actually needed. It maintains some metadata on the current rows, how much data has been archived. Again, you have it keeps track of being able to purge the data. We'll see that later on. Manages the FBA space and retention. So whatever you've defined the retention to be, this background process will start to implement that. It does process the data asynchronously, so it does not affect your transaction performance as opposed to a trigger. Obviously, a trigger has to, when it fires, it's part of that transaction. Typically, it's part of the transaction. Undo data is freed after being processed. Wakes up every 5 minutes, and it can spawn slave processes. So you'll see this FBA process out there, and under no load, you'll just see that. Under heavy load, you will see FBA spawn up slave processes to help it collect and process that data into the history tables. Now, it says 5 minutes. It's lazy, but 5 minutes, I'm finding that shows up in the trace files that I've done for the sleeping of the process. And also there is a Metalink note that says that in a later version of 11 R2 that they changed that to 6 seconds. However, I'm running 11, 12, and I've checked all those, and it's still 5 minutes. So I'm not sure where that Metalink note is supposed to have been, what version it was supposed to have been implemented or got implemented in, but it isn't in up until 12. I didn't see that. I stated this before, but it looks at the undo date in the buffer cache and then from the undo segments. So it's not necessarily dependent on those undo segments. Some of the permissions, when you start to implement this, obviously you need to create table space, because you have to create a table space that's going to be assigned to a flashback data archive. So whomever's setting this out could be your DBA or administrator besides the actual owner of the table, if you so deem that. And then you have to have flashback archive administer if you're going to create the actual flashback data archives, or if you're going to change any of the flashback data archive settings. And then flashback archive is permission, it actually is the permission on the archive that you create for tables to be able to use it. So you would grant a permission on flashback archive to user, and then that allows that user to put tables or enable flashback data archive on the table, and to be able to use that flashback archive. Some of the notes I put here: make sure you set sufficient size for your table spaces to hold historical data. So at the time you create these table spaces, be very cognizant of quotas you may put on it. Also, you would size this for whatever data that you think you're going to be putting in there based on a retention period. So if you're retaining 5 years, then you should be sizing these table spaces to at least accommodate that. What you don't want is space to run out. If you get into space issues, then you could start impacting the actual application that's doing the inserts updates, or you could lose some of your history data. Okay, so that's it. Oh, and users need quota on the table space. So for the users to be able to put their tables in there, they need a quota on the table space that you created for this flashback archive. So the syntax may not be 100% fully complete here on what some of the things you can do and what the defaults are, but this is the general syntax if you're going to start creating these. So you've already created a table space. So now you create a flashback archive. If you say default, what it'll do is just create that as the default system-wide, so that no one has to specify the archive name in later pieces. I don't see where most people would use that. If you're going to have multiple flashback archives based on retention periods, you're going to have a name, and you're not going to just set it globally for the entire database. And then specify the table space you previously created. You can give it a quota. Notice there's nothing less than a meg here, so it's meg, gigabyte, terabyte, petabyte, exabyte. The no optimized data. This is the case where if you did have Enterprise Edition with the optimization pack or option, you can actually specify optimized data and it will implement that. The default is no optimized data, so most shops without that package, you're not going to need that. And then the retention, year, month, day. So this is actually when you create this and you specify, say, 1 day, everything after a day old in the history table is going to be automatically purged. So this is your automatic management of that retention period. So if you have, let's say you have medical records or legal records and you have to keep those for 5 years, you can specify 5 years and know that that data, you don't have to manage it. Come 5 years, that data is going to automatically be purged and that's going to keep current for the life of the flashback archive. So takes out all the additional overhead for you to actually do the purge yourself, query it, purge it, all that good stuff. Default for quota here, it is unlimited if you don't specify. And like I said, no optimize is the default. Syntax for the altering of it. So once you've created a flashback archive, if you're now need to make changes to it, an example or most common would be modifying or adding table space. So if you've created a table space and that was 10 gig, and then you created a flashback archive, but now the 10 gig is not enough and you want to add another table space, and specify whatever size you want. That's how you would do it here with the alter flashback archive. So you can add you can add as many table spaces as you want. Most systems, unless you're in the terabytes, you probably would have a table space dedicated for that, and whatever the operating system limit is, that's what it would be. This would be the case where you're starting to exceed that and you need to start adding multiple table spaces. Also, to modify the retention, so if you've set it for a year or 2 years and now you just something changes with the policy and now you want to reduce that to say 90 days or 3 months, modify retention automatically on it. And then you can do purge, so you can actually manually purge this. So let's say the case where you've set the retention, but for some reason you want to purge data outside of that automatic retention. You can alter the database archive and then flashback archive and then actually say purge, and you can say purge everything, or you can say purge before specific SEN or timestamp. So this, even though there's retention and that is automatically handled for you, you do have the ability to manually exercise this if you need. So let's say you made a copy, clone the database, and you don't want all that history. You can, even though there's retention and everything was already predefined, then you can go in and just purge it. So you have some control over manually getting rid of the records. Some of the permissions I spoke of, this is an example of when you don't have the flashback administer and you try to actually, let's say in this case, I'm trying to create a flashback archive called FBDA daily. I've signed a table space to it. I've assigned a quota and a retention, and you can see you would get no privilege, error 55612 on this because you don't have the flashback administer privilege for creating. Same thing with dropping. So creates and drops alters, you would not be able to do that unless you had that privilege. And on flashback archive, if you've now created the flashback archive and now you want users to start using it, you can't, and they've got tables that they want to add that to that archive, they can't actually do the alter table and enable that flashback archive unless they have the flashback archive privilege. So you can see in this case, I'm altering the table patient, and I'm basically saying flashback archive and giving it the flashback archive name. Had I had that privilege, it would just say table altered. Again, here's the pre-setup for this. Create a table space with whatever size you want. Then create the flashback data archive, and you specify that table space. And then that's when you specify the actual retention or quota if you're going to have one. I don't normally set a quota. I'm doing it here because I was doing some testing with purges and out of space conditions. So that's why I had it set here. But typically I don't set the quota on that just because I don't want to take the chance of running into the issues where the space could run out. There is a background process trace file for that FBDA, and if you did get into that situation, there would be tons of error messages reported in that with flashback data archive space exhausted or out of space, you know, all kind of errors would show up in there. And you'd see some of them in the trace alert log. So that's why I normally don't set the quota. So now that you got a table space and you have the flashback data archive created, now it's time to start enabling these for the table. You can do this either at the time you create the table, or you can come back later and do the alter table. So in the create table statement here, you see where I have just the typical attributes for a table, in this case patient, and then the last thing you specify is flashback archive and give it the flashback archive name that you created. So this is the archive name, has nothing to do with the table space. The table space is tied to this archive, and that's totally different than wherever the table, the create table is actually occurring. Same thing now for alter table. You just basically say flashback archive and give it the archive name. Also, if you're going to disable it, flashback data archive on a table, so now to reverse that process, alter table, patient, no flashback archive. And that would say table altered. In this case, I wanted to show you what would happen. Even though you have the flashback archive system privilege, user has that ability. Even if they try to alter it and turn it off, you cannot do that unless you have the flashback archive administer or sysdba privilege. So there's some protection there in the case where the tables, the user or schema owner creates the table, turns on the security, and for some reason that user now wants to turn off the security. There's a little bit of protection there to say, even though you added it and turned it on, you don't necessarily have privileges to now say, stop doing it. It requires a user with a little higher privilege to take it away. So you get this no privilege. And again, sysdba or somebody with a flashback archive administrator can actually do that. DDL support. So once you've turned on the archiving and it creates these history tables, you still are allowed to do some DDL statements on the base table. Truncate, you can add columns, drop, rename columns, add, drop, rename constraints. You can drop or truncate partitions or subpartitions. You can actually rename the table. And if there are some other things that you were doing outside, like split partition or thing, those aren't supported. And if you had to do those kind of things, there is procedures, packages and procedures to allow you to do that by disassociating the table from the history and then performing your maintenance or whatever maintenance you're going to do on it, and then reassociate it back afterwards. So you can, without losing your history, you still can do those DDL things by disassociate and associate. We'll talk about the issues with doing that from a security standpoint, but it can be done. The data dictionary, if you want to query information about your flashback data archive objects, we have flashback, and I put a star there, so it's DBA or user flashback archive. That'll list all the flashback archives, what their retention days are, when the last time it's been purged, so the metadata around that archive. The flashback archive TS is the table spaces that are behind those archives when you created them, what kind of quotas you may have assigned to the flashback data based on that. And then the most common one you would probably be using is the last one, the flashback archive tables. So that actually lists the table, what flashback archive the table is the flashback archive table name, so the actual history name tied to that table, and what its current status is, if it's enabled or disassociated, things like that. So that'll be the one that most DBAs will be using to get information about the actual tables themselves. So once you alter a table and flashback archive and you give it the name, when you do that, there's three metadata tables that are created as part of the history, being able to keep track of this history. There's a sys FBA hist and object ID. So the base table, in my demonstrations all throughout the slides, I use table patient. That patient's actual object ID and DBA objects is what goes on as the suffix to all these metadata tables. So you'll have a hist one, you'll have a DDL column mapping, you'll have a TCRV, which is transaction table. Now, one thing you'll notice that they may not be created immediately. So if you alter a table, and let's say, or you do a create table, so it's brand new, there's no records in it or anything, you're not going to see any of these tables, even though you've turned it on. It doesn't actually create these until it needs them. And you're not really supposed to query against these tables and I won't say that it's not totally supported. It's not supported from the standpoint of that's how you look at history. We'll talk about how you look at history in a minute, but you're not really supposed to query these tables for the actual history. I'm going to show you examples of querying it for the purposes of describing looking at the data in the past tense. So I'm going to show you the underlying history table. I'll show you that, but it's not really meant for applications to use. And again, if no history is generated, then you won't, none of these tables will likely be created. So you will, what I've seen in a lot of testing is that the actual DDL column mapping and the TCRV, those kind of get created first and relatively quickly. The history never gets created until you actually do something with the data, and then that you'll see that pop up. And there could be a delay. Remember I said it, the Flashback data archive background process isn't running synchronously, and it's not running all the time looking at this, so it kind of wakes up and then grabs everything and then goes back to sleep. So it might take you 5 minutes before you see that table. It could take you a few seconds, and most of the testing I've seen it cycle or create that table and capture that data within like 20 seconds or so, worst case. Again, it's based on load, so it's kind of lazy about collecting that information. So this is what the actual history table looks like. So in this case here where it says sys FBA hist, the 228548 was the object ID for the patient table that I was working on. So the history table copies all the columns from the source table, which you can see here, patient ID, last name, first name, and date of birth. And then it adds the 4 other additional metadata columns. RID, which is basically going to be your row ID. XID, which is the transaction ID, operation, so you're going to see an insert, update, or delete in that column. You could see null if you do some, for XID and operation, you could see those be null if you do like a direct path load or create table as. So you might not see those for direct path operations, but anything outside of that you should see transaction ID and the actual operation. And then you have a start SCN, so when that version was created for that record, and an end SCN for when that was either destroyed by delete or update. And we'll see that in some examples. So it's kind of got given you the range, which SCNs somewhat map to the timestamp. So when you're using timestamps to query, it's trying to find the SCNs for that particular timestamp so that it can get the images of the data in the past or prior images or prior deleted records even. So continuing that example with the history table, well, what I'm going to show you is, so we created a patient table, and now I'm going to walk through a series of steps and show you what the data looks like in this history table as we move along. And then I'm going to show you actually how to query the data irregardless of the history table, or not using the history table. But I want to let you see the underlying structure. So in this case, I insert a brand new row. I select from the history table. There's nothing in it. It doesn't record the very first record. There hasn't been a change. There's no audit of that needed. Then I turn around and I update and I set the patient ID. I basically add 5,000 to it. So that would be, so the patient ID goes from 1 to 5,001. And right after doing that, we query the history table. You can see the row ID, starting in SCN number, transaction ID, and it records what the image was before. So the current table has the current record. This is, again, think of this like the triggers. It's recording the history. It's not necessarily recording what it is in the table plus the history. So the before image there was an insert. The patient ID was 1. So now I'm going to update the row again, and now I'm going to change the last name from Smith to Doe. And now I'm saying patient ID is 5001 because I previously updated. And now I look in the history table and I can see, okay, the original row was updated at 1 with a patient ID of 1 was inserted. And then I updated the record from 1 to 5001. So that record's in there. Notice the last name Doe is not in the history. That we're keeping track of the before image. And then I turn around and I delete the row. And at this time, now you can see the insert, you can see the update of the patient ID to 5001, you can see the update of the last name to Doe, and then you actually get the deleted record. So this is the case where you have all the befores, but if you delete the record, there is no longer a current record. That becomes part of the history. And now you can see the actual delete operation that occurred. So theoretically, you could use this table to look at some of the insert, update, delete activity on your base table. So if somebody asks you, well, how many updates versus deletes do we get from this table? If you have this turned on, you could use this table to actually generate metrics, and even generate metrics over a time period and say, this is the number of inserts, updates, and deletes we get. Now, obviously, there's other ways of doing that in the database with some monitoring and things like that, but you could use a history table. That might be a good example why you might query the history table directly. So now what we're going to do is we're going to use the proper syntax, as of timestamp syntax. We're going to look at the patient table, but now we're going to tell it we want that data as of a point in time. And so what I'm going to do in these demonstrations here is I'm going to walk backwards. In the previous queries, the sequence of events was we inserted in the patient, we updated the patient's ID, we updated the patient's last name, and then we deleted the record. And again, here's the history records for all of that. So right now, the record doesn't even exist in the patient table for that original row. So selecting from it, you can see, okay, the row's not there, and patient. Now I'm going to retrieve the record prior to the delete. Now, since I know from, let me go back one, since I know from looking at this history table, I know these start SCNs. I'm going to use those throughout my example, but typically you would know you might use a timestamp, so as of certain times. But if you had to get to if you didn't know the exact time, you could use these SCNs to do it. So that's what I'm going to use here. So now I need to get the record prior to the delete. So I want the last one that was updated with the last name changed. That also includes the patient ID update. So now I'm selecting from the table, again, as of timestamp syntax. I'm converting the SCN to a timestamp, and the timestamp corresponds to the one of the previous record. So that's the 4911471. If we go back and you look on the very last transaction, that was deleted, and then the one prior, you see the 4911471. So that's where I'm getting these numbers from. All right, and where patient ID equals 5001. So now I'm able, in this case, you can see, even though there's no record in patient for 5001, if I say give me that patient record as of this time, I see it. So from an application standpoint, nothing weird about looking at a history table that's been populated by a trigger and union that with its current record, none of that stuff. Just using the as of timestamp. And then I say, okay, let's get the record prior to the update of the last name. So the patient ID was updated, but the last name wasn't at that point in time. Again, we're doing SC to timestamp. Most often, you'll probably have a to timestamp function with an actual timestamp value in there. But again, for simplicity, I'm using SCNs. And then where patient ID equals 5001. And now you can see, now I'm looking at the table with the last name Smith. So this is a case where the record's not even in the table, but I've managed to be able to look at it prior to the delete and prior to the update, prior to the delete so far. Now I want to get the record prior to the update. So this is basically the original inserted record. Again, now the only difference here is I'm changing the patient ID to 1 because I know I updated it from 1 to 5001. Typically, you're not going to have to query on changes like the particular ID columns. If those were your surrogate keys, those are primary keys, those probably aren't going to be changing. So you're going to have additional where clauses in there that would select the appropriate record anyway, or at least based on a primary key that didn't change. In my examples, I was changing it, so this is why I changed it in the syntax. But now you can see I've been able to query the original record. So no record in the table, I can query the original insert, I can query each update at a specific point in time. And that's the whole point of being able to keep track of this history, have full ability to query it, look at it, and everything without you designing anything additional overhead on the patient table, in this case, or trigger to capture this data, automatically being handled, and you can select it with the as of timestamp. So if you were programmatically doing this in an application, obviously select star from patient is different from select star from patient as of timestamp. But if you know that you're going to have history on these tables, then you would be building in the application code to actually say select star from patient as of system or timestamp, and just always put sys timestamp there, unless there's a different timestamp that you want to look at it. That way the as of timestamp is in all your queries no matter what. You wouldn't have to have two separate code bases for that. Okay, so that's recording the data. Now, what if we need to recover the data? Just like we can select from it at a point in time, and in our case, the record is actually deleted from the table. So if I select star from patient, for that patient ID, I don't get the record. And now I want to recover the original record from history. So this is the original inserted record. You can use the syntax insert into with a select from the same syntax I used to actually retrieve it, get it from the history, put it back into the patient table. So this is different ways of recovering the data based on some human error maybe. And in this case, the second one, I'm actually updating that current record. So I pulled it back, but then I said, wait a minute, that's not really the value, the last value in the history table. So now what I'm doing is, you can actually see where I'm updating patient. I'm setting all columns in that row to equal, get the value of this time, or get the value from history, in this case, right prior to the delete. So I get the patient ID updated value, and I get the last name that was updated. That's the last update I did before I deleted the record. So this is actually doing an update. It could have been an insert, get the last record prior to the delete, same thing. But overarching here is that you can recover from some human errors based on your historical data. Yeah, you could also do this to do comparisons. So I could look at original versus the current record. I can look at current record based on some particular point in time to do comparisons for reporting. So from a BI standpoint, you have a little bit of actual built-in before and after images for comparison, data comparisons. Some of the protection on the Flashback data archive. So the data's in the history table. You know, we saw that the syshist and then some object ID, that's actually protected against data changes. So once that's set up, if you have a user try to go in and actually say, okay, I did something, now I want to try to erase all evidence of that, you can't actually do any DML against that under normal circumstances. So if they try to delete, they'll get an error on there. Notice it says you can't alter it, you can't do DML, and you can't create unique index. But it says unique index. So you can actually, and we'll show this later, but or mention it later, you can create indexes on these history tables. So the first thing that comes to people's mind is, wait a minute, this history table gets huge, and I have to actually run these as of timestamp queries, and I'm going to supply a primary key. You know, what's the performance of running those type of queries? And you can, if you know the access patterns for that historical data queries, you can actually index those columns appropriately. So you can actually create your own indexes on your table data columns in this history table. The caveat, if you have to perform some sort of unsupported operation on a table, remember we talked about this, like you want to do a split partition or something, you need to disassociate the table and then reassociate it later. Well, in that time, as soon as you disassociate that table, this protection is gone. It's lost, or not enforced, I should say. So you can actually say delete from that history table while it's disassociated, and it will delete every single record. And then that's it, it's gone. And there's no history of the history. So without going through some other recovery scenarios. But I just wanted you to be aware that during the time that you have to perform maintenance that's not supported and requires you to disassociate it, when you disassociate it, you're also disassociating the protection against maintaining the data integrity in there. And so just wanted to point that out. That could cause some people some issues. There's a package, DBMS Flashback Archive. This is there in previous versions. I'm not going to cover every single procedure that's in that Flashback Archive, but I want to at least bring the new features parts of this and explain what these are. So the disassociate and reassociate, we talked about that. That's where you got to temporarily disable it to do some sort of maintenance. But one of the cooler things in this whole thing is the register application. So let's say you have a whole patient hospital application, and there's 50 tables associated with that, and you don't want to have to manage all 50 of those tables individually. So let's say you had to do something that required you to disassociate it, and you have to go through all 50 tables to disassociate. Well, this is really what eliminates that need to do it individually. So you actually can create an application. You give it whatever name you want. So it's user defined. So you can call it, patient intake application or sales application. And then you call the add table to application to associate tables to an application name. These are going to be tables that you're going to turn on the actual Flashback archive, enable it or disable it or disassociate and reassociate. So you turn around and add all your tables. This is a one-time thing where you add it to the application that you've registered. Now you can actually say enable or disable on the actual application. So if you had to do maintenance and you needed to turn it all off for whatever reason, you don't have to go through all 50 tables. You can just say disable application sales app, and all of the tables are just, it works as a unit. What you can also do with the application tables that are registered to the application is you can actually say lockdown application. When you do this, all the security tables for that history actually become read-only. So there are some special cases where this may be required in your organization. Most people are probably not going to run in this state all the time, but you do have the ability to lock down all those tables that are registered against that application all in one fell swoop and make them read-only. Now, the difference between what this does and if you did alter table read-only, as you might be aware, you can do an alter table read-only and then drop the table. If you do a lockdown application on it, you cannot drop the table even though it's read-only. So it actually hardens it much more so than if you were to do what this does manually, meaning make it read-only. That doesn't prevent somebody from dropping it. This lockdown application will prevent that. And they kind of refer to it as hardening, application hardening. So the next thing that somebody might ask is, okay, so I have a table out there that I've been using with triggers, and I have a history table, and it already has millions of rows in it. And I can't start from scratch. I need all that historical data. Well, you actually can do that with the package, that DBMS Flashback Archive package. There's some procedures in there that can walk you through, and I'm going to walk you through these steps to actually do it. So there's a procedure called create temp history table. When you execute that, it's actually going to create a table called temp_history, and it's going to be based on the table that you supplied when you said create temp history table. You actually are given the name of the table you want it to create a history for. In this case, it'd be like patient, and then now I have a temp history table that has all the patient attributes in it, plus some of the metadata columns in it, and that's what I'm going to use to actually do the import. You can actually create your own if you want, if you manually put all the attributes in it and do those kind of things, and maybe do an insert append into it, and then you turn around and load that in. But if you walk through the simplest of the steps, this is it. Now, once you get the temp history, now this is where you insert all your historical data from your history table into this table, and then you turn around and call the import history procedure from that package, and that'll actually import all the data from the temp history into the actual FBDA history tables. So now you've picked up, you haven't lost any of the previous history for everything. Now there are some cases, obviously, you may say, well, there's some metadata columns in there about transaction number and row ID. Well, you're not going to know all those, or those may not be the actual values that correspond to the table as it is today. So there are some, when you do this, populate the temp history table, there are nulls allowed for some of those things, or you can actually put values in. For start SCN and end SCN, you would definitely be filling that out with an SCN to timestamp and get the current SCN to do that, so that that's real data going in. Some of the recommendations, if you're going to implement this, these are just some of the typical ones I see for people that have implemented this. Add indexes on your history table. So again, if you know how people are querying the history, not the history table directly, but if you know how they're querying it with the as of timestamps and what kind of where clauses they're specifying, then you can certainly add some additional indexes on those tables as needed. I wouldn't put it there unless you absolutely can justify the performance increase in it. One of the other things is definitely gathering statistics on the history tables, because over time you can see where the history tables become full table scans, and some of those are alleviated with just gathering stats on it. Additionally, creating different flashback archives for different retention periods. So don't create one flashback archive and set a retention and then stick everything in it that doesn't match those kind of retentions. So you wouldn't create a 1 year and then go create tables that you really want purged, the history purged every month, and stick it in the 1 year flashback archive table or archive that you've created for that retention period. So you want to reduce space and fragmentations from purging, so it's just efficient use of the space. I typically dedicate the table spaces to a single flashback archive and not multiple. So remember I said before you can create the flashback archive, you need a table space assigned to it. There is no restriction that says you can't create multiple flashback archives and they all use the same table space that you created. I typically don't do that. I group them together. Again, it's more of a space, managing the space issue. I do not set quotas on those table spaces, because if they fill up, that could cause additional issues for you. And then just being smart about what you put in the flashback archives relative to the retention period. So group all those tables that share the same type of retention, and you can put those all in the same flashback archive. You could get as granular as you want and create individual flashback archives for every set of tables, but that's probably overkill. And so these are some of the most common ones that I've seen. So that it's not an all-inclusive flashback data archive features. There's obviously a lot of things you can do with the purging, the commands to purge and retention, adjusting retention. But I wanted to kind of give you, this is what it is. This is how you simply create it, and this is how the metadata, you could use the metadata to look at it, and this is how you query it. So that's really the focus of the presentation for this for today. And like I said, when I say these are recommendations that I see, or these are examples of errors, a lot of that comes from our dealings with other clients. So from expertise standpoint, we have a lot of people that do nothing but Oracle RAC, Golden Gate, Apex development, Exadata, all the Fusion middleware stack. We do this 24/7, so we come across a lot of different issues from a lot of different organizations. All of them don't do business the same way, and they certainly don't architect the same way. So we kind of bring that knowledge when we talk about some of these features. And even when we go through the actual clients that would do upgrades from 11 or 2 to 12, these are some of the things that we've pointed out to them or helped them implement. And this is more of the detailed Oracle database services, specifically around what we do for administration, what we do for security, backups and recovery, kind of the a la carte of managed services for us. And since we are a Go partner, we do Oracle licensing. We're not really in the business of selling Oracle, but what we do like to do, and we kind of pride ourselves on this, is that when we go into organizations that are doing an assessment, either as part of a license renewal, or they just want to get an idea of their assets for their Oracle assets, then we can come in and say, what you're doing doesn't match your license, you're paying too much, or what you're wanting to do doesn't match your license and you need to pay more. And then also looking at the whole compliance of the security side. So we do a lot of the CIS audits, the benchmark security scan stuff. We actually contribute to it and help edit those things. So we have a lot of knowledge when it comes into securing the database, or at least pointing out the security issues that would cause you to fail a security audit. Most security audits, especially if you're doing any kind of hospital, regulatory stuff for HIPAA or PCI, PHI, credit card stuff, SOX, all that. So that's additional, not necessarily tied to licensing. All right, so I'm going to take a look at the questions now. Let's see if anyone had any questions. I don't see any, so if you do have any, if you could post them in that questions box, and I'll answer them to the group. Otherwise, this is my information, contact information. You can also, if you have questions about this presentation and you just wanted to get some additional detail, or questions around some of the services we do related to even what we've seen in the presentation, here's the contact information for all of that. This presentation will actually get posted by next week, I'm sure. It usually takes two. We post it up on the Neovera YouTube channel so that you can replay it, or maybe look at something again, or pass it on to colleagues who might be interested in seeing this as well. So no questions. I'd like to thank everybody for attending today, and I appreciate being able to take the time out to listen to this presentation. This concludes our presentation today.